Welcome back, ladies and gentlemen, for session 3, the final session of Reset LAN Management Bootcamp possible. So yes, sit back, relax, engage, and without further ado, here's the myth, the man, the legend, your bootcamp instructor, Jeremy Ness.
Thank you, Ryan. As Ryan mentioned, this is our last session, guys. So thank you, everyone who's attended all of these. So with this being our last session, I want to take this time to kind of review the previous 2 sessions. Again, just kind of refresh those. And if you did miss those for any reason, kind of give you insight to some of the content at a very high level. And as Ryan mentioned, these are all posted on YouTube. So session 1 was titled Building a Foundation. In this session, we really kind of talked about different LAN architectures, really pointing out that we feel like kind of a stacked architecture, having multiple switches, and then we have multiple closets, link aggregation across those. It's really kind of the most modern, optimal architecture for connecting switches together on the LAN side, right? As part of that, we also talked about VLANs. Occasionally I hear, hey, VLANs complicate things. And it's true, it's easier to run VLAN 1, but as I pointed out, if we're going to apply quality of service, that's easiest to do at the VLAN level, which we still strongly feel that is important in terms of a voice and video strategy, and also just general segmentation, either for security or keeping down broadcast, multicast domains, right? Next, we touched on spanning tree and the fact that you do really need spanning tree, right? This is our loop prevention protocol. Again, I always kind of mention that the helpful users that love to plug patch cords back on the wall and loop our networks. And there really is a correct way to do this. Again, having enabled everywhere, having the same spanning tree protocol with the rapid spanning tree and the multi-segmentation spanning tree, kind of the VLAN version, matching that across our network and then setting the correct priority. Again, I kind of drew out how you can get inoptimal kind of LAN forwarding by not setting the correct route. Next, we did touch on quality of service. Again, we still feel that's an important strategy to prioritize traffic that's important to us, mainly real-time communication, right? Voice and video. I did touch on the fact that this is generally always EF tag or the expedited forwarding tag. But for some reason, no one ever uses the AF groups, right? Those are assured forwarding. We actually have 12 queues there. So again, even if it's ERP traffic or CRM or whatever our main business application traffic is, might as well assign that a higher priority than the default queue. The default queue, different switch manufacturers have different kind of algorithms around what the default queue looks like. But at the end of the day, if things get saturated, queues get full, we're just going to indiscriminately shed traffic, right? So again, you might as well have your business application prioritized over that, and we can drop Windows updates and people, play in Spotify, right? So and then I very briefly touched on wireless. You guys probably noticed that I did run out of time on that session, which I'll be touching on a little bit more here. But they're really, when we design modern networks, we really, designed for 5 gigahertz and soon to be 6 gigahertz. So I'll touch on that here. Again, in terms of channels on modern Wi-Fi technology, you get those 20, 40, 80, or 160 megahertz wide channels. And we really find that sweet spot is that 20 to 40 megahertz. And then I did briefly kind of touch on the DFS or dynamic frequency selection, being that the FCC did allow us to use 5 gigahertz, but dead in the center of that is, radar communications, either weather or satellite or SATCOM, right? So again, we generally try and avoid those just because if I static my access point on a DFS channel, again, we have to wait at least a minute, if not several more, to make sure that's not being used. If it does get used right in the middle of using a DFS channel, we have to get off that quickly. So then on the right-hand side, with session 2, we talked about monitoring and troubleshooting, right? So we touched on monitoring tools, everything from the simplistic but still useful ICMP or a good old friend ping, right, up to SNMP being really kind of the modern workhorse, CLI being that screen scraping capability, and then API, right, being more of a more structured way to monitor our equipment, right? And when we're talking about monitoring, we're talking about resource utilization generally, right? So CPU, RAM, and then when we're talking about switch ports, we're talking about saturation and amount of available bandwidth. Next, we touch on flow visibility, right? Again, our previous tools will generally give us some idea about the amount of bandwidth and port utilization in our infrastructure. We have no idea what that traffic is. So use protocols like NetFlow, SFlow, IPFix to actually see the metadata around that traffic. So I know who's talking to who, what protocol, what port. And then I mentioned several tools. We can take that a step, next step, being either doing a mirror port, span port, or some kind of network tap to actually just record 100% of the traffic, which gives us the ability to look at the payloads, to get more application information. As mentioned, this can also be really great for a security context. Next, we touched on patching. Kind of mentioned there are several reasons you might want to patch. Of course, the biggest one being security, right? So I really hope any takeaways from that was you really should be getting some kind of CVE feeds, vulnerabilities and exposures from either your manufacturer, which as I touched on can be a little hit and miss how they distribute that information. And then I did mention several government organizations that allow you to consume that information too. As mentioned, we do consume that via API, giving you kind of the most structured way and easiest way to filter that out. Then lastly, I kind of wrapped up with troubleshooting. We're talking about a network infrastructure. Most of troubleshooting is around resources. I'm talking resources, right? Again, I'm talking about that CPU, that RAM, right? At the end of the day, these things are computers, right? And then link utilization, right? Being, again, saturation on uplink ports or on the internet side. As Ryan mentioned, today is, given the very marketing term, supercharge. Really what I'll be focusing on is, how do we future-proof if we are deploying equipment today, right? What are the things that we try and design around to enable you to use that equipment for that, 5 to 7 year typical lifestyle of network infrastructure? And then also be touching kind of some future technologies that are out and maybe haven't filtered down at this level yet on the LAN and the WAN side.
And since this is all about future-proofing, Jared, I'm going to start with some rapid-fire poll questions, folks. So stay engaged. Love your responses on these. And here we go with the first one.
Awesome. So when we start talking future-proofing, specifically, LAN refresh, WAN refresh, I often get the question, Jeremy, how much bandwidth do I need? That's a very difficult question for me to answer because I don't know your environment, right? How many people do you have? How many locations? More importantly, what is your applications, right? Someone that's purely SaaS, just consuming web applications, being hosted applications, versus maybe someone in a marketing firm that's uploading large videos or large graphics, or even to architecture firm where we typically see very large CAD files or large PDFs, right? That's going to vary a lot. As such, on the last slide, hopefully you have that tooling in place that will enable you to answer that question, right? How much bandwidth do I need? As mentioned in the second session, typically our firewalls do store some of that information, right? Traffic graphs or flow information for a certain amount of time, but it's limited, right? So again, we really like to see tooling for that. So in broad generalities, we typically see 1 to 500 megabit being plenty for most of our clients. But again, real broad answer, right? It really depends on amount of people in your environment and the applications in your environment. Firewall sizing, this one actually comes up a lot, right? As part of our LAN practice and security practice, we do size and deploy and configure firewalls for our clients. Just in the last few months, I've had this happen several times where, again, we weren't future planning. I often say, well, how much bandwidth are you using today? And I'm surprised how often someone cannot answer that. But they say, hey, I have a 100 megabit circuit, right? So great, you have 100 megabit. Here's a firewall that can do 500, right? That should give you plenty of growth. And then, again, one specific case, the Comcast or the Lumen rep came by and door knocking, and we have gigabit speed and all this, to where they're like, hey, yeah, great, we upgraded, great, we'll do gig, right? As IT guys, more is better when it comes to bandwidth, right? For some reason, we always feel, hey, we need this gig speed. Well, of course, I just sold them a firewall several months prior that can only do 500. So, hey, Jeremy, why am I not getting gigabit? Like, remember that conversation when you had that 100 megabit circuit and it was working fine, so I sold you a firewall accordingly. So again, I know it's hard to plan and you don't want to over-engineer, over-subscribe, but do plan for these things. We are seeing gigabit circuits be more widely available, but again, budgetary-wise, firewalls that can handle that throughput. Again, you look at the data sheet, as I mentioned in the second session, it was at 6 gigabits or 18 gigabits or whatever, but that's really line rate with zero security services. So again, just one that I see, keep catching clients in terms of, hey, yeah, great, turn it up to a gig. Oftentimes, gig isn't necessary. And more often than not, the firewalls just aren't capable of that. So again, something I see trip up our clients. As far as LAN bandwidth, really we are seeing that the standard gigabit port to any endpoints, desktops, etc., client devices, I should say, is still sufficient, right? I don't see workloads that typically need more than gig to the desktop. But again, I'll be touching on that kind of technology in this session too. And as mentioned in the first session, we do still really feel that those 10 gig interfaces are just really industry standard in terms of uplinks today, nowadays, knowing that the price on that technology has really come down a lot. Again, if it was 5+ years ago, I'd say, yeah, the 10 gig SFPs and the switches that can even support that are quite expensive. And for that time, they were overkill. But in this current refresh cycle, we do see that those are standard, right? So again, gigabit to workstations, 10 gigabit to switch uplinks, and then often 10 gigabit to server infrastructure, especially on the storage side, right? Our SASE networks, we've been standardizing on 10 gig for quite some time now, but really those client-facing ports, if you do have a hypervisor infrastructure, pretty standard nowadays. So let's get on the internet side and the LAN side, right? But we have to touch on wireless, and we've seen this trend for quite some time, right? More and more wireless, more and more laptops being issued opposed to desktops, especially in the little event that happened 2 years ago, right? We see a lot of companies that weren't already laptops scurrying to issue laptops. And I imagine that those laptops would come back on the office. Again, you might have a dock, might be wired, but we are seeing a lot more wireless. So in terms of current and then future proofing, right? The current standard is Wi-Fi 6. Wi-Fi Alliance finally decided in their wisdom to not make me spew numbers and letters all the time, right? So they kind of retroed in this Wi-Fi numbering standard, right? EC being the previous generation Wi-Fi 5. So again, if you're doing any refreshes, this has been standardized since about the beginning of 2021. We did see some kind of pre-certified devices in 2020, but really the beginning of 2021 is when we started seeing those certified devices come out. And generally, any wireless client you buy today, being a flagship mobile phone or a higher-end laptop, is definitely have that Wi-Fi 6 technology built in. I'm a huge fan of Wi-Fi 6. Previous generations, they have a lot more density, but there's really been a big focus on speeds, right? I remember, H11B might be on 11 megabit, and we jumped to G54, it was huge. I mean, in Wi-Fi 6, now we're talking in the gigabits in terms of speed, but there's a lot of technology in AX that is really allowed for higher density, right? They've moved to a kind of a time frequency algorithm. Previous generations, it was kind of a variable length. We've actually moved to kind of more rigid slots. This is much more like cellular technology, right? Obviously, that scale is huge in terms of this kind of time division algorithm for cell phones. Wi-Fi 6 has a very similar algorithm, right? Which again allows for kind of higher density, everyone having defined time slots opposed to more variable. Wi-Fi 5 Wave 2 did have kind of some multi-user MIMO, right? Multi-user, multiple input, multiple outputs, being able to talk to multiple people at once. However, that was only in the downstream. We couldn't go in the upstream that same direction, to where Wi-Fi 6 enables that. There's something called BSS coloring, essentially allows access points to kind of have channel interference, but actually use a kind of coloring scheme to code who says what, and again, allow for very high density where I am going to have that channel overlap. Maybe I do need the 40 megahertz wide Wi-Fi 5 to where these things can coexist better. One of my favorite technologies in Wi-Fi 6 is the target wait time. By default, there's a beacon-in period that your device needs to talk to the access point to stay associated. That's typically 250 milliseconds, right? So your iPhone or Android phone, right, battery power is sitting there with its screen off right now because you're paying attention to me. And that thing is just sitting in a battery, right, for almost no reason. So Wi-Fi 6, we allow the client and access point to negotiate, hey, maybe I'm only gonna check in every second or every 2 seconds, right? It's really lends itself for anything battery powered, especially IoT. So again, some really cool technology in AX that we see enabling modern networks, right? Wi-Fi 6E is just coming out, or I should say product has just started being released for that. Not so much on the clients yet. I think there's a few, right? So that's that same Wi-Fi 6 technology I described, allowing us for more density, more speed. But in that 6 gigahertz space, right? The FCC just opened that a year or two ago. To give you concept of why this is awesome, right? Depending on where you are around the globe in general, right? The 2.4 gigahertz band, right? That's 80 megahertz wide, right? 5 gigahertz band jumped us up to 500 megahertz wide, right? So a ton more spectrum. That's why we can even run channels larger than 20, right? Even being without 40 and 80, and again, 160, not really. 6 gigahertz jumps us up to almost 1,000 megahertz wide, right? So again, a ton more space. We can actually do things like 160 megahertz wide or even 320, right? Again, the wider the channel, the more bandwidth. And Wi-Fi 6 effectively gives us tri-band radios, right? Wi-Fi standards always allow that backwards compatibility. So now I can use 3 spectrums and have multiple streams across them. And again, really exciting for giving these even more dense networks, even more bandwidth. So typically we kind of see Wi-Fi standards being ratified really every 5 to 6 years. That's kind of been the general cadence from our very first 802.11b days, A and B, I should say, to where they've really kept that cadence. But there's already been some press releases of Wi-Fi 7 chipsets being manufactured and tests being done, which is a little crazy. So if you're curious, Wi-Fi 7 is the BE standard, right? Went from AX, now we're at BE. And that's rumored to be finalized in 2024. So we're actually looking at maybe 2 years away from the next technology being ratified. And then typically there's oftentimes a 6 months to year lag with that actually coming out in radios and in client handsets, right? They need it in both places. So hopefully the supply chain is back to maybe some normalcy then, and we'll actually see that technology. So again, something to keep in mind if you're refreshing. I still think 6E is very valid, right? Being that, that 6 gigahertz capability of the Wi-Fi 6 technology is going to be huge, right? And should carry our networks that easy, 5, 6 year kind of refresh. But do be aware Wi-Fi 7 is on the horizon, right? Wi-Fi 7 right now, theoretical speeds are 40 gigabit per second, which is absolutely mind-blowing, right? Again, that's probably 20 feet underground in a Faraday cage standing on top of the access point. But obviously, we're going to get multi-gigabit speed out of that, right? And we're talking about future-proofing, right? I always kind of want to touch on the Power Ethernet standards, right? There's really kind of 3 standards. The last one listed there kind of really isn't, but I'll touch on that. So we talk PoE, right? We've had PoE for a long time that powers our cameras, our phones, our access points. The first version of PoE was the AF standard. That was 15 watts, right? But then really access points pushed us into this PoE plus, which is available at 30 watts. And that's because a lot of these access points, right? You see this 4x4 on the box or 8x8. There's actually could be 4 or 8 radios, right? In there. And then we have all these spectrums, right? If we're talking, hey, we have 8 radios and then you talk on, 3 frequencies, right? That is just a lot of power to operate those things. So again, that's when we saw that PoE plus. So I do see people buying the new shiny AX as awesome. Again, great technology, but maybe you still have PoE access points, switches, right? So when we get in that scenario, oftentimes your access points are kind of going to run in a limp mode or a power limited mode, right? They'll have to power off some functionality. There might be a background screening radio. Maybe your 4x4 only operates at a 2x2, right? So we reduce the amount of radios and streams in it. So again, when we're refreshing, it's hard to buy not a PoE plus at this point. But in addition to that, we also need to take into account our PoE budget, right? So switches typically come in like 370 and 740 watts. So that's something else to keep in mind, right? As we get these power hungry APs, and I can only assume that Wi-Fi 7 APs are going to be even more so. Keep the budgets in mind. And again, PoE plus. And then QPoE, this is universal. It's actually a Cisco proprietary standard. It is 60 watts, but there is an IEEE 60 watt standard. So again, you won't see many manufacturers throwing the UPoE on the side of their box. Again, Cisco proprietary, but most vendors out there do have it as 60 watts. Don't see any access points in that right now. It's typically, from what I've seen, reserved for outdoor cameras that might have heaters, right? If you live somewhere very snowy or very cold, you don't want that piling up on your outdoor security camera, right? And also the ability to have kind of dehumidifying and getting rid of fog. So again, things keep it in mind. Hey, newest technology, make sure I have enough. My switch infrastructure supports that, and lot of those bandwidths I threw out are crazy, right? I mean, Wi-Fi 6, we are seeing, clients pulling out hundreds of megabits, no problem, right? One client. If I have that 5 to 10 people, right, and they're using high bandwidth applications, I can easily oversaturate the LAN port, right? That LAN port just being single gig, typically to most access points. So in 2016, we saw this coming down the pipe with AC Wave 2, was this ability to have this multi-gigabit, right? So again, IEEE and these working groups got together like, hey, how can we get more than this 1 gigabit, or doing a link aggregation on access point, right? Getting 2 gigabits to it, knowing that a single stream can really only go as fast as one of those. So we do have an IEEE standard, the 802.3BZ. And this really describes the ability to do 1 gig, 2.5 gig, 5 gig, and 10 gig over a standard, copper 100-meter cable, right? So sometimes you see this called N-base-T or MG-base-T. That was really the IEEE working group, right? But N-base-T is kind of the umbrella underneath the 10 gig protocol to describe this, right? So different manufacturers, again, we need to be differentiated, and we can't call things all the same. So again, we're Cisco Meraki fans, right? They call this technology M-Gig. Cisco calls it multi-gigabit. Juniper also calls it multi-gigabit, which I'm amazed that Juniper and Cisco can actually call something the same thing. Thank you for making our lives mildly easier. Dell calls it multi-gig in their marketing. And then Aruba calls their smart rate. So again, all these different technologies, really are this 802.3BZ, even though vendors might call it something differently. Then on the right-hand side, right, due to different cabling, right, we're talking about Cat 5e, 6, and 6a. Really what we're talking about is twists per inch, right? The more copper we have. And 6a also has some noise canceling. Oftentimes there's a separator in the cable, right? But really, the more twists per inch, the more throughput we can do. So most of you probably have Cat 5e in the walls, right? That's been our industry standard for really decades now. And over the standard, again, that 100 meters or 330 freedom units in feet, right? We can do 2.5 gigabit. Like I said, today, this is really mostly access point focused, knowing, hey, on an AX access point, I very much real world have the capability of going over gigabit, on the Ethernet port, right? If I have Cat 6, right, that allows me 5 gigabit, and then 6A, 10 gigabit. We are seeing desktop technologies also starting to adopt this too, right? Right now, if you buy a high-end gaming keyboard or a high-end workstation, fairly common for these to have 2.5 or 5, or again possibly 10 gigabits to the workstation. So again, when refreshing switches, when refreshing wireless, really keeping track of that kind of that PoE, and then the ability to really allow those access points to gobble up as much bandwidth as we want. Well, if we start talking about 5 gigabit to an access point, and I have 10 access points on a switch, right? All of a sudden, my uplinks become more and more important. As I mentioned, we still view 10 gig as kind of a standard, but in a stacked configuration, that's actually 20 gig, right? If I'm doing link aggregation, or if I'm doing a physical stack, again, switch to switch is typically going to be 25, 50, or 40 gigs, right? So we start talking about switch uplinks, right? As mentioned, 10 gigabits really kind of been the standard for quite some time, with the price of switches with the SFP plus ports and the optics themselves starting to become more reasonable. Other uplink technologies and speeds we have is the 4100. I did place those kind of together because they are similar technologies being created around the same time, right? So both of these were actually a stepping stone off of 10 gigabit. So 40 gigabit, even today, is typically 4 10 gig lanes, right? So equal our 40 gigabits. Then 100, when it very first came out, was actually 10 gig lanes. However, they've since moved on because that's a lot of power and just a lot of silicon and wiring inside of a typically an SFP form factor, right? So the newest standard is 2550 gig, right? So single lane of 25 or 2 lanes of 25 gets us 50. With 100 typically being now in modern 100 gig is going to be 250s, really, so 425s. So I think we're going to start seeing more and more 2550 coming out, knowing that's the newer technology. Not that 40 and 100 isn't perfectly capable. typically don't see 100 gig in most environments, right? That's typically still more a data center technology. There actually is a 200, 400, which again, I think is outside of the scope of everybody on this call. But we are starting to see 100 gig uplinks, and we're talking about 10 gig aggregation switches, right? So if I have a large campus and I want to do, link egg to 10 gig interfaces to all my closets, pretty common now to see kind of a 10 gig aggregation switch, right? So oftentimes it's two 16 ports stacked or two 24 ports stacked, right? Kind of in our core, often we do layer 3 there. Typically, those are going to have 100 gig uplinks. Just due to, if I have, 24 ports of 10 gig, obviously 10 gig uplinks don't work, right? So again, things just keep in mind as we expect more and more bandwidth to go across our switching infrastructure, especially with access points really pushing that. And something just keep in mind. When we were talking these ports, all these flavors do come in kind of two physical mediums, right? The first one is DAC, the direct attached copper cable. This is kind of the cheapest, easiest way to connect things in 10 gig or 25, 50, 40, 100. Being it's copper cable, typically 1, 3, and 9 meters. Having the really SFP kind of plugs on the end, right? Or just really kind of molded in. So again, if you're inside a single rack, very common to do that. And that's typically what our stacking cables are too, right? So if I stack, typically DAC, or if I'm cross-connecting across the front of the switch, right, if I'm doing that link egg. The other way to do that is via fiber, right? And then I kind of touched on the session 1, but really want to kind of, emphasize here again that we do have, multiple types of fiber. Multi-mode seems to be the most common inside of a premises. Single mode has typically been a little more carrier grade, right? And the reason for that is single mode is a much smaller core, so I can actually go a lot farther because the light doesn't, bounce and kind of lose, steam over time. So OM1 kind of comes in 4 flavors, but really in the real world we see 2. I would see OM1, which is typically your orange fiber, right? So if you have fiber, again, connecting closets and it's orange, no, it's OM1. No, that is a very old standard. I mean, you can't get very far on 10 gig. I think it's sub 100 feet at this point. So the more modern would be OM3, which is our aqua cable. So again, if you're installing any new, cabling, make sure it's at least OM3. And these cannot mix and match due to the core sizes, right? So if you're in OM1, your patch cores also need OM1, same with OM3. However, with 10 gig and potentially 25, 50 gig coming down the pipe here, 10 gig, we can only get about 1,000 feet, a little over 1,000 feet over that OM3. So again, if we're thinking future proofing, really looking to do more single mode, again, 10 gig or even 100 gig, we're talking many, many thousands of feet over that. So again, future proofing, if you're looking at net new fiber infrastructure, really single mode is where we're kind of seeing most people want to be headed. So that kind of concludes the physical pieces. And if we're making purchasing decisions or planning our LAN architecture today, those are kind of the big highlights that we see. Everywhere from sizing our firewall correctly, sizing switches correctly, make sure we have PoE budget for the newer access points, and then making sure that we're not saturating our access point ports, right, via 1 gig. So now maybe talking more technology trends and things that we probably see, several years in the future coming down. So not a new trend, but we're starting to see it accelerate in different ways, is utilizing controller-based networking, right? So this has been the wireless space for a long, long time. Being that, if we deploy switches, we have, 5 or 10 in our environment, we kind of statically configure them. But wireless, we can often have many more of those. And if we want to make a policy change, right, it can be painful. So for a long time, we've seen, Aruba and Cisco and Ruckus have a on-premises, wireless controller, and there's others to control those access points. Kind of a big push we're seeing in this space is going more cloud-based and extending that not just to wireless technologies. So again, yes, Cisco Meraki, of course, one of the first cloud dashboards, but we're even seeing Cisco Traditional do it via their DNA Center Cloud product. Again, Aruba Central, right? That was wireless initially, but they're really pushing at the switches, right? Even Ruckus, right? They've gone more full stack with their switches and wireless, and again, that can be cloud-based. Juniper made the Mist acquisition, right, for their access points. We're also seeing, right, them push kind of their cloud dashboards also into the EX switching line and the SRX firewalls. And then, of course, I have to bring up Ubiquity. They've always been kind of that cloud-based. or excuse me, controller-based. Now you can kind of a cloud key. It's not really cloud-based, right? It's still more of that cloud key, but again, seeing a lot more of these, kind of cloud-based controllers. And there's huge advantages of that, right? Being that we need connectivity to all the endpoints of the controller, right? So again, if I have a large wireless infrastructure, I need private connectivity or public connectivity. I guess another one I didn't call out again is FortiGate, FortiFabric, FortiManager, same idea, right? Kind of full stack. But again, all of those things, devices, access points, and a WAN do need connectivity to that controller, right? So even if I don't need VPN tunnels for business case, oftentimes I have to do them for connectivity to that controller. So again, cloud allows us just, hey, if you have internet, you can access the controller. That's awesome. But cloud also generally has kind of that NetFlow information in it, right? That actually takes a lot of horsepower. In my previous organization I worked at, we had 130 sites, and I was taking NetFlow data off of all those. And it took 8-core VM for the analyzer just to display that information. A very large database. It took a lot of IOPS, right? If you're really recording metadata about every flow in your network from a lot of sites, that's a big lift. So we do see the power of the cloud being that kind of elastic compute, having that capability to take on that load, right? Another trend we're seeing that does need that kind of cloud elastic is AI, which is not AI. Come on, of course we need to throw that sticker on. Really, it's event correlation and modeling, if we're really going to call it what it is, right? Not to say that's not positive. We've first seen this in the wireless space, right? Wireless can be very difficult to troubleshoot. Going through the logs can be a pain. The correlating events, right? As clients move around our network, why are they dropping? Why is it slow? A lot of this, can be, have event correlation for that troubleshooting. So we've seen a lot of the vendors come out with that piece, and now we're starting to see that move into the LAN infrastructure too, right? In terms of correlating, like, hey, this person's slow, and I see network port errors, or hey, I see the MTU's wrong, or trying to surface a lot of this information when you have to dig through the logs and dig through counters, trying to surface that and again correlate events, right? Hey, I saw the DHCP was very slow, or DNS or web traffic slow, and it might be because of this thing. Which again, really do need to do at cloud scale. Those event correlation, algorithms do take a lot of horsepower, right? Which typically can't be done on that controller on site. So again, not new, but we are seeing a very fast progression in it and seeing things added to it to make our life as network administrators easier. This next several are really kind of more future technologies that I think there's a good chance we're going to see in our LANs in the near future. So SD overlay, SDB, and of course SD software defined. We do see that more in the WAN, which is actually the next slide. I'm going to kind of touch on technologies we're seeing there. But we're starting to see it more on the LAN side. Right now, this is more data center campus, right, with the kind of these overlay technologies. So typically in those environments, they're all layer 3, but we still need layer 2 adjacency oftentimes. So these overlays allow that. VXLAN is probably the most common, being a virtual extensible LAN. And again, data center, but we're starting to see a lot of these kind of SD overlay tools use that to where, again, we get a lot more intelligence when we encapsulate the traffic, right? To where do prioritization and security. The other big one we're seeing, again, still data center, hyperscaler, but a lot of times that technology is going to trickle down environment is EVPN or Ethernet VPN. Again, allowing kind of layer 2 adjacency over a layer 3 infrastructure with policies wrapped around that. And then Lisp, not really an overlay, but it's a protocol that's used in many overlays. I have to look this one up, guys. It's the Locator Identifier Separation Protocol. Kind of the biggest adopter of this is Cisco, especially in their SD access. So again, they're a large campus kind of overlay technology, right? So as mentioned, a lot of this in the data center is still in that Cisco ACI and VMware NSX, but we're starting to see that get pushed out more and more into our LAN environments. And then next one, again, little niche, cloud scale, but I wouldn't be surprised if it gets introduced and trickled down into some of our smaller LAN environments being verifiable or closed loop architecture. So this has to do with automation, right? I'm going to make changes, but I want it to be verifiable, right? Hey, I pushed this out, and did the change get set? Was my intention met, right? If I'm changing how my traffic flows, did that actually happen? Those can be difficult questions to answer when we manually do something, right? You whiteboard it, hey, I think it's going to work this way, maybe you lab it. And be able to verify it is really important, right? Did my intention get met, right? So when we talk closed loop, we talk, hey, we deployed a change, are we able to verify that that change actually happened? Did it get taken across my infrastructure? And are things flowing in a way I want, right? Again, this little niche for specific products, but I can see it rolling out, especially to our controller-based hardware, right? Next one kind of flows in this, right? Intent-based networking. Right? We're always used to programming VLANs and quality of service and tagging things. Would it be better if I had, hey, network, I want to prioritize this thing, right? This is more important than this. This person, just talk to this person, right? If I could somehow, say business policy in some human words, right, and put it in my controller-based, wouldn't that be awesome? So again, we are seeing these technologies. Again, they're large right now. No reason not to expect them to trickle down into our environments over time. Then last one also kind of plays into this space, right? About overlap here, dynamic segmentation, right? Up to this point, we typically set up VLANs and we untag ports, and we might have some 802.1x, right? We use a PKI and certificate-based authentication. But we're seeing more and more of this, again, rolled into some of these SD overlay technologies. The big one in this space has been a NAC for a long time, right? Network access control. We're starting to see that not be a standalone product, right? We're seeing kind of simplification of that being rolled in to our LAN environments. And again, security and quality of service. So that's it for kind of the LAN technologies, but we're really seeing LAN and WAN really starting to kind of mix these boundaries, right? They always used to be real obvious, right? On my edge device, a firewall, that my switch, my access points. But we're starting to see that edge device not be an edge device how we've typically always thought of it, right? It's always been a NATing router. It's always where we do our security policy. It's where we terminate, client VPN, site-to-site VPN, to where now we're seeing LAN technologies that are, again, really blowing those lines, right? So I'll be doing a brief whiteboard of these. Again, if you've familiar with Matrix and many of our other education sessions, we've dug into both of these a lot. So again, I'm just going to really do a high level of these. So again, SD-WAN, software defined. To me, software defined, at least in the networking, as I like to say, that typically we have a next top mentality, right? If we use dynamic routing like BGP or OSPF, right, we're populating route tables with what's the next hop? What's the next hop? Well, if I have multiple ways to get there, typically it's a kind of weighted round robin or some kind of priority to where we don't know anything about the traffic or anything about the quality of the links, right? So software defined, again, is an overlay technology, which allows me to answer the question, what's the quality of the links? What's the traffic over the links? Which link should this go over? It also helps for resilience and redundancy. And we've seen that as a standalone product. Again, kind of very early, VMware is one of the pioneers with a standalone kind of SD-WAN product. But there was no firewall on that, right? So security was difficult. A lot of times we're still backhauling. Again, we've seen a lot of these edge devices kind of bolt on SD-WAN on the side, right? So still my edge device, but now, site to site, and then depending on the type, site to internet, I do have this awesome, multipathing and overlay. However, again, we're kind of seeing a consolidation, right? As I talked in the last slide, a lot of these things are starting to get folded into one and be cloud-based is SASE, right? So again, I won't go too deep on this just because we had a whole SASE series a few months ago, 3 sessions again. First one, me talking about what we do about SASE, and then kind of 2 vendor spotlights. But really, this is cloud delivered security and cloud delivered network. To mention, this is really kind of blurring those lines of where we're collapsing these technologies into each other. So again, SASE, secure access service edge, really is kind of a notion of a cloud firewall. But more than the firewall, right? Again, that cloud delivered security. So again, when we're talking about SD-WAN, and very briefly here, we typically add 2 endpoints, right? This could be site to site or site to internet, right? And typically they have one path between them, right? So if I'm accessing an application, typically add one path to it. If I have a site to site VPN, I very much only have one path to it, right? So of course, what's better than one path? 2 paths. However, firewalls are typically pretty bad. Again, they don't have that software defined piece. They don't know the quality of the links. They don't know which traffic should go over each one, right? So we talk about an overlay, right? We can have the underlay, typically the internet, but it could be internet and private connectivity, right? So we build actually close to kind of a single IPsec, right? We kind of build this overlay, and they can do link steering and all that SD-WAN goodness. Which again, used to be standalone products, right? Velo Cloud, and then we got CloudGenix and Viptilla, and there's many others in the space, but typically they're always lacking that security piece, right? And oftentimes they weren't cloudy. They're purely site to site, which is great. But now that we're seeing a lot of our applications move out of the data center, right? Move out of the on-prem, no longer in the closet in the back, right? First, I feel like we got our email taken away from us, which thank God, who wants to administrate an Exchange server? Then we saw a file server taken away if you have Office 365, a SharePoint, and OneDrive. Oftentimes you saw ERP or CRM, which was many machines in our environment, hopefully virtual, but it's always a database backend or backends resiliency, front ends, load balancers, all kinds of stuff, right? If you're hosting your own website nowadays, man, we saw that move away, right? So as we start consuming more applications, right, that site to site makes a lot less sense to where, really we want site to internet, some kind of connectivity again with that kind of multi-pathing. And like I said, a lot of edge firewalls do that for us today. So again, the latest architecture we're really starting to see, again, coined by Gartner, being chased after by everybody. If any of you are IT people on LinkedIn, I have the unfortunate title of CIO. Man, I'm getting SASE constantly, right? But again, SASE really is kind of cloud delivered security, right? As things move out from behind the edge, right? As the applications move out, edge security starts making less and less sense, especially with people, working remote, right? My security controls are back at the data center or back at headquarters. My users aren't. So, it's a poor user experience to try and shove their traffic through that security. Again, in this paper, Gartner kind of mentioned, hey, opposed to forcing your flows through your security, you should put your security where the flows are at, right? So again, this is generally going to be some a cloudy security, and this can be everything from firewalls as service, secure web gateway, DNS, right? Kind of all the acronyms you'd expect. Except SASE also has a notion like a single pass architecture, has the idea of context, right? Each engine should know about the other one. It should have an idea of identity. In previous products, especially the edge, a lot of times you were several products, again, consolidation in the industry, right? Of course, I need to get to this, right? Cloudy thing. I want it to be close to me. So points of presence, as Gartner has called out, is very important, right? I want this thing to be as close to me as possible to reduce latency. And as I kind of showed on the last diagram, right? I want really robust connectivity to it, right? So that SD-WAN piece is now just a piece of a SASE platform, right? And per Gartner, that box should be dumb. Very first slide I really touched on today was sizing my firewall correctly. Well, I'm doing that because every vendor has 20 different models, and they have 20 different models because it has different CPU, RAM, storage, because I'm trying to do all this at the edge. Well, in the true SASE environment, the thing is more or less dumb, which is just a simplification of things, right? It's kind of job in life is to create these SD-WAN tunnels. And in the SASE architecture, we put the security engine in between everything, right? Again, nothing Gartner called out, right? Since we're doing cloudy security, typically we don't kind of do this site-to-site capability, knowing that all this traffic can be sent through a SASE platform, right? And then remote users. This is kind of the biggie, right? In terms of during this pandemic, very early on, we did sell a lot of Cisco Umbrella and other tools to try and get visibility, right? Typically, you're gonna have some EDR, some endpoint detection response, but we just doesn't give us the visibility, right? That's kind of a last resort in my mind, right? This EDR. Hopefully, I'm stopping anything nasty way before it ever gets there. That's just a defense in depth, probably my last layer of defense, right? So, can have my end users connect to the SASE platform, and especially if they're distributed, right? That's a huge part of cloud. Of course, where you saw the big cloud providers have all these regions, right? US West 1 and 2 and East and all that, right? And again, we're peered with all of our favorite SaaS providers and UCaaS, voice providers, to where again, anything on site, it's still there. Anything going out, we have all this visibility. And as I'm seeing more IaaS, right, infrastructure as a service, aka Azure and GCP and AWS, right? Typically, I can deploy some kind of virtual thing and they become part of my SASE, right? So again, consolidation, single pane of glass, I have to say it. We're really seeing that the industry move that way to where now, arguably, the cloud is my network, right? I answer whatever is the closest cloudy thing. So as I mentioned, really blurring the lines between what's my LAN, what's my WAN, where do my apps live, where do my end users at, how do they get there efficiently with security, right? Again, the great thing about SASE is now I don't care if they're here or there, right? I'm able to supply the same exact policy for them. So with that, concludes really the main kind of meat here of session 3. Again, in this, we really talked about how do we future-proof, right? If we're sizing new infrastructure, thinking towards the future, not kind of shoehorning myself in equipment that isn't going to work. I'm going to have to go ask for my own budget later on. Again, future technologies that we're seeing, really the huge push to controller-based, cloud-based, again, for that scalability. Again, a lot more overlays, I think, are in our future. And then a lot of this just getting more and more cloudy, right? Really blurring the lines of software defined on-prem and software defined in the cloud. So with that, we have one of our favorite SASE vendors on, Kevin Clausen with Cato. So Kevin, can you come on and tell everyone why we think Cato is one of the best SASE solutions out there?
Yeah, absolutely. Thanks a lot. Great session, Jeremy. Kevin Clausen with Cato Networks. We're a partner with Matrix, and Matrix are a very, very valuable part of our partner community. And before I talk about Cato, I know Jeremy's done this a few times, but just a level set on the definition of SASE, right? Because it can get a little murky. In the Gartner definition, which is also Cato's definition, SASE is the convergence of SD-WAN with the security stack, right? Firewall as a service, CASB, the secure web gateway, anti-malware, zero trust network access, and so on. It's also cloud native, and it's built for full visibility to all traffic from all edges, the physical, cloud, mobile, including traffic between the edges, the WAN, and from the edges to the internet. And that includes that ever elusive single pane of glass that we've all been hearing about for many years. That actually is a requirement of a true SASE solution to manage and derive the analytics from the SASE solution, through that one pane of glass. And so what isn't SASE? It's the opposite. It's not chaining a bunch of point solutions or a bunch of separate network and security appliances together. And it's not about having multiple dashboards to kind of manage everything. So what we do, as you can probably guess, is we're providing a converged network and security stack over an optimized private global backbone of about 70 POPs right now, with meshed redundant IP transit providers between all those POPs, so always on. And our solution extends to the branches, to the data center, and to the remote access employee as well. And it's all managed through a single dashboard. So our converged software stack includes SD-WAN, and to us, SD-WAN is simply a feature of SASE now. SD-WAN used to be a standalone, exciting product. Kind of like a long time ago, you could get auto attendance separately for UCAS. For us, SD-WAN and best of breed SD-WAN is really just table stakes for any good SASE solution. And we're also providing the network security stack as part of that software stack. And because that security stack is cloud delivered and managed by Cato, customers are no longer burdened with a lot of the headaches of doing the patches and the updates and the CVEs when there's another vulnerability. And there's always a vulnerability, right? So for example, when the Apache Log4j occurred about 2 months ago, customers of ours using intrusion prevention system were already patched. Those that hadn't already been compromised in some way had nothing to do because they were immediately solved for through our SOC and through our managed network. And so we're also reducing on the security side the attack surface significantly. Kind of the old way of doing things is every single location was its own context because you had your own appliance, your own firewall. And what we're doing with the cloud firewall is we're creating full context awareness for the entire enterprise. And that includes the remote worker, the data center, the branch. You can see everything, you can control everything, and that reduces a lot of human error and risks and really does reduce that attack surface. And then we also have a remote worker. We've talked about that. It's a nice alternative to the AnyConnect and to legacy VPN services. Our POP backbone acts as VPN concentrators. So a lot of those, issues with capacity that plague traditional VPN go away. And so as a partner to Matrix and as part of their kind of MCAS offering, I thought I would, kind of walk through how Cato can enhance and secure a, let's say, UCAS provider, being that, Matrix work with best of breed UCAS services, and they bundle our services in. So what Cato is going to help do for that UCAS service is we're going to provide middle mile optimization. So we're going to be able to direct all UCAS traffic across the best path available, and then whatever path has the least latency and packet loss across that network. So that's one benefit. The second is application optimization. So we can actually drop the UC traffic at the Cato POP closest to the customer's UCAS instance, also minimizing latency and packet loss. And then last but not least, we're going to be able to secure that UCAS service against network attacks across all locations connected to the Cato cloud. So hopefully that gives you an idea of how those kinds of elements work together for us. That's pretty much all I've got. If you want to know more about Cato, the team over at Matrix are Cato experts, and they'll be happy to answer any other questions. Thank you very much, and I'll pass the mic back to Matrix.
Beautiful. Thank you, Kevin. Thank you to Cato Networks and all of our sponsors, including Big Leaf and Entirety. We aren't able to dedicate the time and resources it takes to put these events on without them. But most of all, thank you to Jeremy for sharing his knowledge and experience with us over these 3 sessions. It goes without saying, but I'm gonna say it anyways. Everything we have discussed throughout this boot camp are products and solutions that we can provide you as a trusted partner. Plus, who wouldn't want to work with Jeremy, right? A great first step and something we do regularly for our clients is performing a network audit. This is generally the first step in our MNet solution, our Matrix Managed Network Administration service. This, along with internet optimization, endpoint security, cloud phone systems, contact center, and much more, are core areas that you can leverage to make your team and yourself look like the IT rock star that you are. Did I write that down? Yes. Could you tell that I'm reading? Yes. But again, thank you for attending Reset. Don't forget about our bonus session tomorrow. This session is presented by the owner and CEO of Matrix Networks, discussing the financial impact of a healthy network. It's a great session for you all to invite your senior leadership to, and there'll be a follow-up email with a single link registration to that you can send them. But that draws boot camp to a close. Hopefully you love the content. We plan to make this an annual event. Looks like everyone has said they want to make this an annual event. Jeremy's not happy about that, but we'll be back next year with fresh content for y'all. And then don't forget about Tech Mixer 10, right around the corner in October. Hopefully we see a lot of you there. But until then, thank you for joining Reset. Hope you had a great time. We'll see you next year. Cheers.